How are y'all doing? I was working on changing my batteries for my calculator, but I only have three AAA batteries in the whole house, and it needs four. So I'll work on that this afternoon after class, I guess. All right. Oh, let me get this here. Here we go. Hope this will be enough for today. That should be enough. So rather than use the graphing calculator today, I'll use the other calculator to demonstrate these things. Hopefully I'll have the other by Wednesday when we review for the test. So I hope everyone's doing alright. And sorry for last week. Just got kind of crazy. So anyway, hopefully you've watched the videos from my other class to get caught up. I linked them in the Canvas announcements, I believe. But yeah, so we're going to wrap up Chapter 3 today and then review on Wednesday. And then Monday will be our first test. Now, technically Monday is the day of the test, but what I'm going to do is I'm going to give you a window of time, basically from probably Wednesday evening or maybe even Tuesday evening this week until Tuesday evening next week. That way you'll have you can take the test anytime during that period, but you'll only have one attempt of the test. So once you start taking the test, you need to finish it. So you could do it during class time on Monday next week. We won't have a normal lecture on Monday next week. Or you can, if you prefer, you could take it some evening in between if you feel like that's when you'll be more comfortable taking a test. It's really just up to you at that point. And I'll set it up as a Canvas quiz, and you'll be able to log in and take it there. Okay. Do you have other questions about the upcoming test? Okay. Let me get turned around here. Sorry. There we go. All right. Well, we're actually going to talk about that today. I feel like we have enough time. Yeah, chapters 1 through 3. I feel like we have enough time today to go ahead and talk about all of all of section 4 and section 5, which goes over all the quartile stuff, which goes over all the percentile things from section 4, and also the outliers. And then we'll talk about section 5, which is again about another visual sketch that we'll use. Okay. I probably don't need my textbook right here in front of me. So, Section 3.4 covers measures of position and outliers. Now, when we talk about measures of position, basically a measure of position tells us a data value's location in the data set. Is it in the top half or is it in the bottom half? Is it in the first 25%? Is it the 96th percentile? Whatever it is that we're interested in. For those of you that have children, especially young children, when they go to the doctor, your doctor will take their height and their weight, and they may tell you, hey, your child is in the top, or they're in the 60th percentile of height for kids their age, which means they're a little bit above average in height 50% being average. And they may say that your child's in the 45th percentile for weight, which means they're a little bit below average. So that's one way in which we use percentiles. Another way is in when you graduate from high school, for instance, and you get your ranking at the end, and you may be told, hey, you're in the top 25% of your class. Well, that's fine. And it turns out that if you're in, I think it's the top 5 or 10%, then you automatically gained admission to any public university in Texas. I think it used to be 10, but now it's 5, which, anyway. You still have to pay, of course, but in all likelihood you'll have scholarships in that scenario. But so I think that's what they do with like top graduating high school seniors, for instance. So that's another way in which we use percentile, but basically it's a way of measuring a position in the data set. Like, where is this data value in relation to all the other data values, is basically what we're saying. Now, we're actually not going to worry so much about position. We do have a measure for this that we'll talk about more later, and this is actually in chapter 7, where we discuss what's called the z-score, which is basically a measure of position in the data set. And we'll talk about it more when we get to that point. That's a little ways off. In the meantime, we're going to focus instead on quartiles. So I want to talk about that first. We have our quartiles. The first quartile which we'll call Q1, represents the 25th percentile. Okay, the second quartile Q2 represents the 50th percentile. We actually call that the median, because the median is the middle point. That's the 50th percentile. So this is also the median. And then the third quartile which we'll label as Q3 represents the 75th percentile. Now notice we only talk about 25, 50, and 75%. If we talked about the 0%, that's basically the minimum value in the data set. And if we talk about the 100th percentile, it'd be basically the maximum value in the data set. We'll come back to those concepts a little bit later today. So whenever we find the quartiles, we tend to find the ones that are actually in between the minimum and the maximum, and that would be Q1, Q2, and Q3. Although we don't really call this Q2, we'll actually just call it the median. Okay. So keep that in mind. Now, depending on our data, there's different ways we can find this. We can find it by hand, or we can find it using the calculator. Certainly the calculator is going to be the easiest way, especially if we have a lot of data. But I wanted to show how we can find this just with a given data set that we can work with. So let's look at our data. In this case, we're going to go back to the same one that we've been using at various points throughout this chapter. And we have, I believe this is 9 data values overall. First thing we do is locate the median. Do you remember how we found the median here? Five. So that's our middle value, 5. And again, technically, it counts as the second quartile. Now the median divides the data into 2 halves. We have the lower 50% and the upper 50%. Now, for our lower 50%, the first quartile, Q1, is halfway between. Okay? So in that sense, if we take the part of the data that's below the median, if we get the midpoint of the lower half, then that should give us the first quartile. So for these 4 numbers, what would be the median? Because we only have 4 numbers, we know the median will fall between the middle 2. So if it falls in between, $1.5, right? We take the 1 and the 2 and add them together and divide by 2 equals 1.5. So that's our first quartile. Now, for the top half of the data, we do the same thing. Median is right here, so it cuts it in half. So in the top half of the data, we want the median of these 4 values. Now, again, when we have an even number of values, the median falls between the middle 2. So what number is halfway between 13 and 21? $17, right? And that's our third quartile. Okay, so that's how we can think of it. The median is kind of, we know this is the middle point of the entire data set. And then if we think of the median as dividing the data set in half, then the middle of the lower half is Q1 and the middle of the upper half is Q3. And so we get Q1 is 1.5, the median is 5, and Q3 is 17. Now, that's how we would do it by hand. Like, procedurally, we'd think it's the midpoint of the lower half and the midpoint of the upper half after we find the median. Now, in our calculator, let me clear this out first of all, although I'll probably regret that later. I'm already regretting it. So I'm going to have to enter those in later, so that's fine. Yeah, that's good. So if we take our data here and enter it into the calculator, let's say 1, 1, 2, 3, 5, 8, 13, 21, and 34. We've got 9 data values. 34 was our 9th value there. And again, press second stat, go down to 1 var stats, enter, 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 and we get our statistics here. Now, we already know how to find n. This is how we find standard deviation, Sx. X bar, that's our mean of these values. We'll be asked to find all of these on the exam, and you'll see it on the practice test as well. But then at the bottom we have these values here, the minimum. Then we have Q1, median, and Q3. You see you get 1.5 for Q1, median is 5, and Q3 is 17. And of course it says the maximum below that. But we were interested in those three in particular here. So we can find that either way, and especially like on the review and then the test where we have 20 or more data values. I think it's 20 to 25 is the range of numbers I gave you. In that case, it's probably easier to go ahead and use the calculator to find all these things, just so that we can be certain that our answers are correct. Especially for like the standard deviation, where it's a much more difficult calculation by hand. Now, I intended to get some batteries, fresh batteries in my graphing calculator so I could demonstrate on that. I'll make sure I have that. I'm going to go to the store this evening, so hopefully I manage to remember to buy some AAA batteries. That remains to be seen, if I remember or not. But I want to have those for the review. That way I can demonstrate how to use the calculator on both types of calculators, so when I turn y'all loose to take the test, you won't have any confusion in that regard. Anyway, actually the TI-84s are a lot closer to what you're seeing on this calculator, only it's not a graphing calculator, is the difference. The style of answer or method of entry that you see on this calculator is closer to the 84 than the 83. So if you have an 84, that's fine. But any of the three calculators will work. The 36X like we have here, the 83s or the 84s, which are the more expensive graphing calculators. But as you see, this one will work perfectly fine for everything that we do this semester. So if you're just trying to get it out as cheap as possible, this is what I would recommend. Okay. I'm just saying, if you have an 83 or 84 already from like previous class or high school, you can definitely use that here. Alright, so that's how we found our outliers, both by hand and on calculator. Okay. Or no, that's how we found our quartiles. We still need to find outliers. That was what I was trying to lead into there. So let's find, or look at how to find outliers next. It does involve the quartiles, instantly. So to find outliers, we calculate the following. First, we have what's called the interquartile range. Which we'll call IQR for convenience. IQR is equal to the difference between the third quartile and the first quartile. So basically it's the range of values covered by the first and third quartiles. Okay. Second, we calculate what's called the lower fence, which I'll abbreviate as LF, appropriately enough. Our lower fence is equal to the Q1 minus 1.5 times the interquartile range and third, we'll calculate the upper fence, which you'll be surprised to learn is abbreviated UF. UF is equal to the third quartile Q3 plus 1.5 times the IQR. Okay, so we have to find IQR first, of course, because we then use that in both of these calculations. So now we have a lower fence and an upper fence. So the way that we define an outlier is any data value that is not between the two fences. Okay, so when we say it means it's not between the two fences, that means it's either lower than the lower fence or higher than the upper fence. So what the fences do is they kind of provide a boundary as far as where we hope our lower and upper values will be for our data, but anything outside of that would be considered an outlier. Okay, those would be our unusual values. So let's go back to our list of data values and see if we have any outliers. All these formulas are on the formula page. If you remember, I added a formula page to the to Canvas in the file section. I also put calculator instructions in there too. Both of those will be available on the exam. So what I'll do is I'll probably take the text of those documents, convert it to an image, and then include that image in the header of the test. That way, that information will be included in what you have available for the test. So you can refer back and forth to that as necessary. Okay, so there's our data once again. And we said Q1 is 1.5 and Q3 is 17. We just need the quartiles to figure out where the outliers may be. Now, before we can actually figure out if and where we have outliers, Let's look at our interquartile range first of all. I missed an 8, you're right. Thank you. So our interquartile range, again, we said that was Q3 minus Q1. So we'll just take 17 minus 1.5. And that would give us a 15.5 as our interquartile range. Next, we want to calculate our lower fence. Now, our lower fence is Q1 minus 1.5 times the interquartile range. And I put these in parentheses to indicate that we need to complete this operation first before we do our subtraction second. So Q1 is 1.5. We'll plug that in. And then 1.5 times IQR, which we said was 15.5. Now again, we can complete this calculation first and then do the subtraction, or if you prefer, there we go. If you prefer, we can do all of it at once in the calculator. Make sure you subtract, not add. Oh, never mind. I see what you're saying. Yeah, 1.5 times 15.5 is 23.25, and then we need to subtract that from 1.5. What I would do, and again, this is, whatever you prefer, is if you're willing to use the parentheses button on your calculator, we can just take this whole expression and input it into the calculator and get our result. So whether we say, okay, this is 1.5 minus 23.25, multiplying these first to get that answer and then subtracting, or just doing it all in the calculator, either way, we'll get a lower fence of negative 21.75. Does that make sense? Okay. We'll repeat that same process for the upper fence. Now our upper fence does have a little bit different formula. It's Q3 plus 1.5 times the IQR. Well, Q3 is 17 in this case. Now our IQR is still 15.5, so let's plug that in. So this product is still 23.25. We don't have to multiply that again. The only difference is, instead of subtracting it from 1.5, we instead add it to 17. So this ends up being equal to 40.25 as our upper fence. And if we repeat that on the calculator, we should end up with the same result. It is important that we put parentheses in there on the calculator so that the calculator knows to work inside the parentheses first and then do the addition or subtraction second. Or you could do it like we talked about here, is do this calculation first, and then do this subtraction, and then do this addition, because this number is the same in both cases. It's just 1.5 times IQR. Alright, now that gives us our fences. So that means our lower fence is negative 21.75, and our upper fence is 40.25. Now, we look back at our data. Are any of our data values lower than negative 21.75? And the answer is no, because our numbers are all positive for starters. Looking at these, the lowest one is 1, and that's lower fence is certainly further down than that. So if this is our data set, our lower fence would be way over here. Now our upper fence, we said it was 40.25. Well, 40.25 would be a little closer to 34, but it's still beyond 34. It's higher than 34. And so every data value would actually fit nicely between the two fences. So what does that tell us about the outliers in this data set if all of the data values are between the fences? We have no outliers, yes. So a number, a data value, which would be any one of these 9 values that we have, these can only be outliers if they are higher than the higher fence, upper fence, or lower than the lower fence. Okay. All of our data is nicely between those two numbers, so there are no outliers. So let's look at a data set where we do have an outlier. Save this from the last time I actually had a board to work on and a class to teach in front of, so, like physically. I'll just write them down once again. These are the same data we've been using for the other, in the rest of the, actually chapter 2 and chapter 3, we've used this data set quite a bit. Now the problem here is that we, 1, do not have the data in order, and 2, there's more of it, because now we have 20 data values. So we'll probably go ahead and use the calculator to find Q1 and Q3 for starters. But then the rest of it we have to work out just by our calculations. Okay. So that's our data. Now again, in our calculator here, I'm going to press the data button, and I already entered that data in the L1, so I'm going to use L2 this time just to not erase the first data. Theoretically, I could have just put this in there at the beginning and just not deleted anything the whole chapter or chapters. But I feel like the repetition as far as seeing how this is entered is helpful. After each number, we press enter, making sure not to enter the numbers too many times. I'm going to speed up a bit. Of course, speeding up leads to more mistakes potentially. I can totally see a mistake I just made. come back to it. Okay. Yes, I like to arrow up and look at these and see. Well, there's clearly a mistake there because 3 wasn't any of our data values. That was actually supposed to be, it's right after the 45. And then that would be 23. There we go. We have all the formulas available, and the way that for this data, what we would do is we have to arrange them all in order from low to high, and then we do the same thing like we did with the other data set, which is to see if I have it here. Yeah, we wrote the data from low to high, and we found the median here, and then we found the median in the lower half and the median in the upper half to get Q1 and Q3. And then we just use our equations for IQR, lower fence, and upper fence to find them from there. It's a little bit more arduous to put, like when we have 20 data values, put those into order. But one of the things that we do in the test is we create a stem and leaf chart, which effectively puts them in order for us. And you'll see that on the review also. Okay. Alright, I'm going to check the rest. Hopefully, we've got all those entered properly. So I'm going to go second stat. We want one variable stat. So this time, I stored the data in L2 because that's in our second list. So I'll make sure I change that over. Keep frequency as always 1, and then just enter calculate, and that should give us our numbers. One more. Okay. So we can see Q1 is 18.5, and then Q3 is 26. So we'll go ahead and use those values. So Q1 is 18.5, Q3 is 26. Okay. On these calculators, if you ever want to get out of this table, there's a quit button. Actually, both on the graphing calculators and this one. So you just press second and quit and get back to the normal screen. That's always helpful, I find. Okay, so we need to go ahead and calculate IQR, which we know is Q3 minus Q1. So we subtract those two numbers, and what is that, 7.5, I believe? Okay. Next, we want our lower fence, which is Q1, 18.5, minus 1.5 times the IQR, 7.5. So we fill in those values. Our lower fence is equal to for that I get a value of 7.25. What is the value of the upper fence? So what is the upper fence equal to? Does someone have that? 37.25. Good. Okay. So any data value smaller than 7.25 or larger than 37.25 is considered an outlier. So any data value smaller than 7.25 or larger than 37.25 is an outlier. Do we have any outliers in this data set? For 45, right? Right. Now, our smallest data value is 18, and none of those are smaller than 7.25, so we know we're good there on the lower end. But on the upper end of things, our upper fence is 37.25. That means we have one number that's larger than that 45, which is definitely an outlier in that case. Okay. Does that make sense how we found that? Hopefully. Okay. So that takes care of section 3.4. Basically, it's on finding quartiles and then outliers, and we did it with two different data sets, so hopefully that's nicely illustrates the process. Let's move on to section 3.5, which is on what we call the 5-number summary. And we'll also look at creating a different type of graph called a box plot. Okay. Now the 5-number summary is actually something we've dealt with all those numbers. We just haven't given them a collective name before. 5-number summary consists of the following values. We have the minimum, Q1, the median, Q3, and the maximum. Okay. So previously, we talked about the minimum, the maximum, and the median in section 1, I believe. And then we introduced Q1 and Q3 in section 4. So all 5 of these numbers together make up what we call the 5-number summary. And we're going to use these 5 numbers to help us create what's called a box plot, which is a different way of visualizing a information or a data set. Okay. It's also a helpful way to compare multiple data sets if we have box plots for different data sets. I'm trying to keep some things collected together. All right. Now, box plots use the 5-number summary. They could potentially also use the fences and the outliers, if there are any outliers. We can make a more complicated version of a box plot. Not more complicated, really. It's more involved, I guess, or more descriptive. We can make a second version of a box plot that incorporates the fences and any outliers as identifiers on the box plot, and make it a little bit more detailed in that regard. So that's actually what we're going to do, because we can make a real simple box plot. Let me show you what a box plot looks like. First of all, before we dive into actually creating them from data. So box plots, these are a visual representation of data sets. Using the 5-number summary. And sometimes using the fences and outliers. So the basic concept would be like this, where we have a line, and let's say underneath this we have a number line which maybe has markings that we can follow. So we want everything to be adequately spaced on this box plot. Okay, and so we have a point for the minimum and the maximum, and we might have a second point for the median, and then points for Q1 and Q3. Okay, so essentially, and what I've done is, instead of putting the box plot on the number line, I put it above it, just so we can kind of line everything up vertically, visually. So our minimum value for whatever it is that we're looking at is a little bit less than 0. Q1 is around here, median is around here, and Q3 is around here. It's important that everything's equally spaced, because the distance that these are apart being different than the distance that are separated here is significant, and helps us analyze the shape of the distribution, whether it's compact, whether it's spread out, all those same things that we're analyzing in sections 1 and 2 by comparing the different elements of the data. So we can do it visually from the box plot as well once we create it. So to create the box plot, we mark each point 1, 2, 3, 4, 5 from the 5-number summary, connect them all with a line like we've done here, although technically I drew the line first because I'm terrible at drawing straight lines, it turns out. Vertically, we put a box around the middle 3 values here. So I draw a vertical line through Q1, the median, and Q3. and then close up the box on top and on bottom from there. Okay. Now, this is sometimes called a box and whisker plot because we have a box in the middle and two whiskers coming out from either end, one on either end. So, some textbooks you'll read call it a box and whisker plot, but more formally, I guess we would call it a box plot. Okay. So our median is here, Q3, Q1, minimum, and maximum, which I forgot to label. But that's basic setup. If we know what our fences are, we could also include the fences, like maybe our lower fences here. We'll draw a bracket, and then we'll draw a right bracket over here for the upper fence. And if there are any outliers, we would mark them with an asterisk. In this case, because all of the data is between the two fences, there are no outliers, so we wouldn't worry about that. So as a comment here, we would mark outliers with an asterisk. If there are any. Okay. So if our lower fence, instead of being right here, had been right here, this is our lower fence, that means the minimum is actually outside the fence. We would put an asterisk above it to show that that's an outlier in this scenario. So the box plot that we use is a little bit more involved than what we might see, like your standard graphing calculator creates a very simple box plot because it doesn't have the ability to include all these details that we're including. Okay, so we'll actually make a little bit more of an involved box plot. Anyway. Let's go back to our data that we've already worked with. And so again, this is our first set of data that we worked with in section 4. 1, 1, 2, 3, 5, 8, 13, 21, 34. And we found Q1 is 1.5. Q3 is 17. We calculated the median was 4, halfway in between. No, median is 5 because the 8's there. That's my bad. 5 is the median, 1 is the minimum, and 34 is the maximum. And we calculated the lower fence and the upper fence. Let me just write all that down without calculating it again because we've already calculated it. So our 5-number summary, we have our minimum value is 1. Q1 is 1.5. The median we found was 5. Q3 17.5. And the maximum we found was 34 just by looking at that. That's the maximum. We said that the lower fence was negative 21.75. Our upper fence was 40.25, and we have no outliers. So that's kind of summarizing what we have here. Okay, so to create a box plot, I'm going to make a number line first of all. And I have to include the numbers from 1 to 34 at least. So I'll start at 0. I'm going to count by 5s. 5, 10, 15, 20, 25, 30, 35. Median is, oh, Q1, Q3, 17, right. Thank you. And what I'll do is come back and make 4 marks between each number. Try to equally space these, although it won't be precise. But then that'll be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Okay. So our minimum value is at 1, which is right here. So I'm going to make a point at 1. Q1 is at 1.5, so I'll make one right next to it. It kind of looks like it's at 2 though, but I can't really help it with the level of detail we have on my sheet of paper here. Median is at 5. Q3 is at 17. And the maximum is at 34. So draw a line connecting these 5 points. Around the Q1, the median, and Q3, I'll draw a vertical line. Now close these up to create our box. Okay. We also noted that the lower fence is at negative 21.75, which is way down here, so I'm just going to draw a bracket off to the side. And our upper fence is at 40.25, which is a little bit closer on the right end because it's just the next mark over from 35. So I'll draw it closer together, but we have no outliers, so there's no other marks to make beyond that. And so that would be our box plot for this data set. Okay. Now, what we can see by looking at this box plot there's a couple of things going on here. One, because our median is kind of to the left side of this box, like we have this outer box here, and then the median is kind of toward the left, closer to Q1 basically than it is to Q3. And because we have a shorter whisker on the left hand side than we have on the right hand side, those two things in common, both those things tell us that the data is skewed to the right, meaning that our data is much more closely packed together in this part of the data set and gets further and further apart as we go to the right. Well, that's kind of what we expect with the Fibonacci sequence, which is what the basis for this data set is. We keep adding two numbers together, and the larger and larger the numbers get. And so, but stands to reason, it will be skewed right. Almost, it's guaranteed, basically, by the creation of the data. So, but I mean, that's how we would tell visually, looking at the box plot, that's true. And we would see it if we graphed the histogram for this data also, which is that on the left-hand side we have a shorter whisker, and on the right-hand side is a longer whisker. That means it's skewed to the left. Same thing as if the median line is closer to Q1 than it is to Q3. It also tells us it's skewed to the right. Sorry. Um, I think I said skewed left once, but it's definitely skewed right in both senses. Um, because we have a longer tail going off to the right, basically. So we know this is skewed right just by looking at it. Another thing we can tell is, based on the size of the box to the entire length of the line, it will tell us whether the data is spread out or compact. This one's kind of in between because the box takes up about half of the overall length of the line. Just visually speaking, it looks like about half the length, which means it might be relatively evenly distributed, although I think it ends up being slightly spread out. And when we calculate whether it's compact or spread out, I would prefer you to use the method we learned in section 3.2, which is to compare the range divided by 4 with the standard deviation. And whichever one's bigger, then that tells us what it is. We could certainly look based on this graph, but I think it's more effective to actually compare those two values to determine if it's spread out or if it's compact. Like I said, this one, because the box is relatively about half the size of the entire length of the line that we drew, it's probably fairly evenly distributed, but overall, I think it ends up being slightly spread out as a result. Anyway. Alright, then we go to our stats class age data. I'm not going to write it down again, but we found Q1. Actually, our minimum in that set is 18. Q1 we found was 18.5. Median is what was the median? We just had it. Sorry. Going back to the calculator. Median is 20. That's again where we would find it, is from the calculator, rather than doing it by hand. Q3, 26, and then the maximum 45. So that's our 5-number summary. And again, one of the nice things about the calculator is that the last 5 values it gives us is basically the 5-number summary. Okay. We also found the lower fence is 7.25. The upper fence was 37.25. Yes. And then we did have an outlier of 45. Okay. So we start at 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay. And I'll make 4 marks between each number. Okay, so 18 will be right there. 18.5, a little bit to the right of that. Median is at 20, which is not much further to the right. Q3 is at 26, and the maximum is at 45. So we draw the line connecting those points. The middle 3 points, we have vertical lines going up like that. Close those up, and that's our box. So again, it's Q1, the median, and Q3. We draw vertical lines there, and then we close them up on top and bottom with the box to create the rest of the box plot. Okay. And again, we want to mark the lower fence. That'll be a 7.25 and 37.25. And when we mark the bracket, make sure the line itself is where it's being marked, and then the other parts basically tell us which way it's going. 45 is an outlier, so we'll mark a asterisk there, and this would be our box plot for this data set. Are there any questions here? Now, there's a couple of graphs that we'll need, or charts that we'll need to create for the test, and you'll see this on the review when you look at it. Hopefully you've already started looking at it, and if not, it's okay, but I do encourage you to look at the review between now and Wednesday and go ahead and work on it some. That way you can kind of see where you stand right now, and then I'll go over everything in class on Wednesday, and then that should give us everything we need to prepare for the test, because the exam will be just like the review as far as the questions that are being asked. What'll change is basically the data that's provided that we need to use for the question. Okay. So for the problem where we have to create a histogram, and then the problem where we have to create a box plot such as this, you'll draw it on your own paper, and then you'll have to upload it via a photo or a scan of your paper into that problem in Canvas when you take the test. And I think the same will be true for the stem and leaf plot. So for those problems, I just want you to upload an image or a scan of your work. But make sure you include the same details that we have here. Okay. The rest of the problems will either be multiple choice, or matching, or fill in the blank, basically. And you'll see when you go through the test, like the first couple of questions, like from chapter 1, all that's going to be either multiple choice or matching, because each case is basically one thing or another, so I can set it up easily as a multiple choice question in Canvas. The sampling methods I can do like a matching problem, because we'll just use each method once, which should help. I think, process elimination is definitely a valid approach. But then the chapter 2 and the chapter 3 stuff. The chapter 2 stuff is more fill in the blank with some. You'll have some charts to make that you'll have to upload the images for. And then the same thing with chapter 3. It's a combination of fill in the blank and making a chart here for this problem. Okay. So let's go ahead and stop there. I don't have any homework for you. I just want you to work on the review mainly. The review doesn't have to be turned in, because I'm going to go over the entire thing on Wednesday. But I encourage you to look at it in between, just to kind of see where you're at, so that help you see where you're at as far as this material, and that way you maybe after Wednesday know a little bit better what you might need to focus on in terms of preparation. Okay. And then again, from Wednesday until like next Tuesday night, you'll have a window of opportunity to take the exam. And then again, you only get one chance, but I'll give you a time limit of like, I'll probably give you a 2-hour time limit, even though our class is an hour and 20 minutes. I'll go ahead and give you a little bit of extra time just to account for the fact that we do need to upload files as part of it, so I want to give you time to make sure you get all that done. Alright? And hopefully that, yeah, so about 2 hours. Yeah, because I want to allow for extra time just for technical difficulties, and if you really run into problems like you get locked out of the tests, or like if you lose your link and then it won't let you back in, just send me an email and I can open it back up for you or whatever. So make sure it's a good reason. Well, like, but you know, if you start and you stop, then I can't really help you. But if if there are technical problems, let me know. All right. So we'll go from there on Wednesday, just working on the review. But y'all have a good rest of the day and take care, and I will talk to you then. Have a good one.